Hi everyone, thanks for checking out another InfoSec Hub video. In my last video we touched bases on the SIEM, the Security Information and Event Management System, and these are the eyes and ears of the SOC. The SOC is the Security Operations Center. Well, a Security Operations Center is usually hired when you have an infrastructure, can be on-premise, but it can also be in the cloud, and you don't have either the knowledge or the people that are willing to monitor it 24/7, and when an incident occurs that they log in and check what's going on. So this kind of, you can call it maintenance or service, can be done by people that run a SOC. But the SOC need to be fed with data, and the data comes from the SIEM, and the SIEM is filled with data from different sources. I think that's a good way to start the video. So here, let's see. So the SIEM is located here. It basically is a database, and that means there is a lot of data. Where is all this data coming from? Well, if you have a firewall, for instance, you have a log file of the firewall. So what is going on the firewall? What are false positives? So you can tweak the firewall just optimally for your business. So you have usability, but at the same time you have security. You need to find a balance between that, because if you really set the firewall rules too high, then people cannot work and things will be blocked and things will not be loading at the endpoint, which is the laptop, for instance. But then again, so we have a switch. Let's say this is the main switch. This is where the internet connects with the local area network, where all the workstations and laptops are connected with. The switch has logging going on. Each laptop has their own logging going on. So let's say, for instance, a person clicks on a phishing link, then logging from either Google Cloud, Azure, or maybe even locally will be fed to the switch, and the log switch contains all the logging of the servers and the workstation and everything, and it will be fed to the SIEM. So basically all the computers, either a laptop or workstation or a server, have logging going on, what's going on. You also have logging going on to say, this is the CPU temperature. If you want to keep track of that, you can do that. If you don't want to keep track of that because you know that the cooling in your data center is all right, you can switch it off. You can basically, on your needs, tweak what kind of information you want to see, because every endpoint and every server pushes out logging, and there's a lot of logging going on, and that's why we have a SIEM, basically to keep track of what's going on and what you find important. Well, one of those things that can be important and that is important is, of course, IDS and IPS logging. With this, you can see, all right, we have this infrastructure. The firewall is standing in between the internet and my local area network. What kind of requests are coming through? And can we see if there are certain patterns that are malicious? What are the rules on that? Let's say, for instance, somebody knocks on the door of a server to see which port is open. Do we want to log that? Probably not, because this happens all the time. But do we want to see if user action, so not an automated tool, but really user action, performs actions on a server to see what they can do with this open port? I think you would. And we want to be alerted by this. And we want to make sure that we keep track of it, and we check the logging, and we see where the IP is coming from. We see what the user agent is that they're using. And we want to see, to a certain degree, what their intentions are. Of course, you can have an IDS and an IPS. So an IDS is the detection system. It detects something is going on which is suspicion, and the prevention systems say, okay, this is suspicious based on our policies, and now we're going to close this connection, that the attacker does not have any connection to the target system anymore. So basically you stop the attack. because everything flows through the network. On that level, the network level, we close this connection, so the attacker from a certain IP address or a certain user agent, which could have a fingerprint, browser, OS operating system version, whatever you want, it's a fingerprint of the whole system. Based on this fingerprint, we're going to close the connection to this system. So that could be an option. Let's say, for instance, that you have a firewall on local premise, you have a firewall in the cloud, because in the cloud you have all your servers, or you have all your servers here on premise, or you have a hybrid solution. Doesn't matter what your infrastructure is, you want logging from all sides flowing into the SIEM. So it's all here collected in an aggregated database, and it can be a Splunk solution. There are many solutions out there, which I will not go into detail about, but SIEM is basically all the logs flow to one system, and you can, with filters and dashboards, make sure what is interesting for you to say. And it's basically, it's always a risk-based analysis. Which systems are more critical for your business? Where is data stored that is most critical? If we lose this right now, we cannot work, we lose money, people might, who knows, might be the case, right? So you make a risk-based assessment on what's most important for you, and based on that you set a dashboard and you set triggers, in short. So log parsing and enrichment, so it parses the logs, extracting key data fields, IP addresses, timestamps and event types. So IP addresses, very logical, that's unique, you can see where it's coming from. Timestamps, do we see this IP address or this kind of attempt or event coming back over like every hour, or is it random? And if it's random, then it might be user action. If it's coming back on certain events, if it comes back every 15 minutes, then it's automated, especially when it's like on the second, because then it's a computer on the other side that's just doing some kind of scripting and just performs a task, or it's a person that thinks, okay, this doesn't work, then I'll try this. So that's the attack pattern. So then this rules and threat detection is also fed and this is basically what we're looking for as patterns. Multiple failed logins. You can say, okay, after 3 failed logins, you are blocked from logging in for another hour. That's a way to mitigate these password dictionary attacks. Malicious IP traffic, we see it's coming from a VPN, so we don't know exactly what the origin location is. If we have an IP table of all the VPNs that are in use, we say, okay, you cannot allow our servers to go through the VPN. We block this. Might not be very user friendly, because lots of people use VPNs also for legitimate and privacy related background, but it could be a way. Unusual login locations. Okay, I log in now from the Netherlands, but in 1 second later I log in from Mexico. Not possible, so this is a red flag. Excessive data transfers. So we see something is happening. One server all of a sudden is pushing out 50 gigabytes of uploads a day, and it used to be 1 for 24 hours. What's going on here? This is a trigger. Lateral movement. I think, and this is an assumption, I think this is also when you now log into one location and then another location, and you see you're going through the network with your credentials and with your IP, and you go through the network. So you log in on one computer, you might elevate your privileges, then you go to another computer and you jump from system to system, and all of a sudden you have the right rights and network rights to access a certain server which contains data that you want to access, delete, copy, or execute your ransomware attack. We need to see how you're moving through the network, right? And the last one, privilege escalation attempt, is actually what I just explained. You start as a user, and all of a sudden this user promotes itself to admin rights, and all of a sudden I have more privileges, and this lateral movement I can do. So I can jump from one server to another. If I'm onto server A, I might have a remote desktop session into server B, and that's actually my target system, and now I'm there where I want to be. And because I have admin rights, I have more options. I can load scripts, I can install programs, and this is what it has to do with this privilege. So that's why it's always key to have the principle of least privileges also, and identity and access management is also really important. Only system administrators should have all the rights that they need for their job. So not all the rights by default, everything they need for their job, also an admin level. And you need to escalate it, and when you escalate it, so you go from a normal account, user account, to admin privileges, you need to fill in a reason. And this cannot be blah, blah, blah. It really needs to be a specific reason, because that's company policy. You want to be able to have an audit log based on what's happening. So now we have all these kind of triggers set up in the SIEM. Let's say we have the firewall is under attack, or server A is under attack, and we see unusual traffic and unusual patterns on server A. I want to have an alert, and we can then have manual action taken care of on the server, or by default we say, okay, as soon as this happens, I want you to completely block off the server and isolate the server. That means something to the service at the end. I understand that, but this can be a company decision. If you have critical data and it's worth lots of millions and millions of dollars, then it can be a company decision that we have somebody somewhere in the world always on standby and taking shifts to make sure that we monitor the traffic to this server. It really depends on what the goal is and how valuable this data is. You can also have a setup to say, okay, we have production site A that runs 24/7. We make copies every time to location B, and when something happens to A that we're not sure of, we only lose like 30 minutes of work, and that's an acceptable risk. And in the case something happens to location A, we switch to B, and then B becomes A, and A becomes B, right? So then we always have something going on, and we make sure that we guarantee the uptime, and we guarantee there is no data loss. Yeah, maybe half an hour, okay, but we accept that, and we say that to our customers, put that in the SLA, and then everybody's well aware of this. It really depends on what business you work, what the risks is, and what always, as always in this world, how much money is involved. So this is basically the SOC SIEM. No, this is a Software Operations Center. So they do investigation and analysis based on the alerts that the SOC team... sending alerts to the SOC team. Sorry, I have to read it differently. So when the SIEM detects certain things, you want triggers to be sent to an operator, a human being who can recognize these kind of patterns based on his experience. So the SIEM, again, they are the eyes and the ears, and the SOC is the brain. The brain is always a human being. You might think, yeah, it might be replaced by AI in the future. But who says this brain cannot be corrupted by attackers? I think that's also a very important thing. What I find in information security, we can automate everything. At the end of the day, you're going to need a human being to see if these alerts are false positives or not, based on experience. And yeah, you can train an AI bot or whatever, but also legally, I don't know if you want to be protected by a bot or just a human being who has experience. I will always choose the human, always. No questions asked. But that's my personal preference. We'll see what the future will do. But this SOC guy can put out automated actions. So if they can have rule sets, let's say this attack happens, then we automate that this port is closed. We can block IPs automatically. Let's say 3 times attempt, okay, automatically block your IP for 24 hours. Then we monitor if this IP comes back and tries something else. And then we have all these kind of events because it's a security incident and event manager. And it can track actions based on IP, based on user agent for multiple days. So you get history behind it. You can think about it. You can maybe have an AI bot think, okay, this is what they tried to do. And then we can cross-reference it against our policies. Do we need to sharpen them? Do we need to loosen them? It's a constant cat and mouse game that goes on 24/7. And I'm really astonished by it. I understand that the SOC is the brain because the human beings, I said it, they're still more capable than AI bots, but all these automated tasks and certain attack patterns will never change. They will not change. It's just a certain way that an attack is performed, and that goes back 20, 30, 40 years. So that's an attack pattern that will not change anymore. That can be automated, and then when the SIEM detects this, the SOC can say, okay, when this happens and we get this alert back to us, then I want you to do this action. We can already do that. What they can also do is quarantine devices when they say, okay, we see suspicious traffic coming out of it. Let's say one of your endpoints is now part of a botnet. It connects to a command and control server. We want to make sure that you quarantine the device, put it to factory settings or install it completely brand new, and then make sure that the malicious code that's on the device is essentially wiped out that way. Or we can disable accounts. Without an account, you cannot log in, you cannot have access to your resources, and you're not starting up the code that actually started this mess. So that could be another one, and that could be automated. Let's say your account is now in the Netherlands, and 5 seconds later it logs in from Mexico. That's a big red flag. We disable your account in a second. Right, so they cannot do any further damage. But you need to automate these kind of things to be quick to respond against the threat. That's what it's about. Now, continuous monitoring and improvement. It's kind of like the PDCA cycle: plan, do, check, act. It's continuous monitoring, continuous 24/7. We know about the power of big data. It's the same goes for security. Let's say you have a small company with 7 people. You don't have the money, you don't have the license to be part of the big global block lists that are, if your neighbor reports something that's malicious and suspicious, then it's also part, you paid for this knowledge, which is big data, to also be part of your company. So if your neighbor reports something, you're protected as well. But of course, in the license structure of, let's say for instance, Microsoft or Google, this costs extra. But it really depends on the threat assessment. How many employees do you have? What is your endpoint protection? What is your awareness level basically within the company? What kind of data are you holding? Do you need to have it available on at the snap of your finger? Or is it okay if 5 hours go by without you being able to access the data and still get work done? It really depends, and it all starts with threat assessment and risk assessment. As you can probably figure out, I can do this for hours, but I think I made a good summarization of, I summarized the SIEM quite well. Again, I'm not a technical guy. Only thing I know is concepts. And if you talk to me in concepts, I understand it. I understand what the reason behind is. I know to a certain degree what's going on, based on work experience, but also based on experience in my private life with my own network. That I know of the existence of these kind of tools and the power of these tools. And you need to have eyes and ears in this landscape nowadays, because threats are changing overnight. So big data and the aggregation of data it's so vital to stay on top of this. With that being said, I hope you really like these videos. I got new energy to make new videos and make this channel more interesting, hopefully, and attract more people to information security, because it doesn't matter what's going on nowadays with all these new technologies, with AI and fake news and all these things. They come their own risks there. We live in an information age right now, and the internet is both a fantastic phenomenon that has brought so many people closer together, but at the same time it also creates a lot of risks, especially in today's geopolitical landscape with I will not call the names, but who has an offensive security program, and those are mostly located in the East, and they have set their targets on us. We are, especially here in Western Europe and America, we are very, very much digitalized. We have a good network. We have a lot of things connected to the internet. That's a big risk. It's a great opportunity, but at the same time it's a big risk, and we just need to know of this, and we need to make sure that we have things going on, spot it early, have automated responses to incidents set up, have alerts going on, and I see information security is booming for the last couple of years already, and I don't think it will stop anytime soon. Have a great weekend. Thanks for watching this video. I hope you find it interesting. If you have any comments on this, please let me know in the comments below this video. And that's it. Thanks for watching.